the zinc solid reacting with the acid aqueous, where the zinc dissolves, giving the zinc 2 plus aqueous plus the hydrogen gas. There is another reaction where if you put a piece of zinc, just like the way you put a piece of zinc in acid, if you put a piece of zinc metal into a copper ion solution, like copper sulfate solution. So I write Cu2 plus aqueous. Okay? What will happen is that you will see that this zinc is also slowly dissolving into the solution. Okay? It does. Zinc 2 plus aqueous. But what you will see that the copper metal is slowly depositing. Initially, copper was 2 plus aqueous in this solution, but you will see the metallic copper is getting produced solid. Is this reaction balanced? I have one zinc on the left, I have one zinc on the right, I have one copper on the left, I have one copper on the right. I have 2 plus charge on the left side total, I have 2 plus charge on the right side. So everything is balanced. The net ionic reaction is balanced. Right? So who is getting oxidized here? Zinc oxidation number is changing from 0 over here to 2 plus. So that must be zinc must be losing electron. So losing electron is the oxidation, isn't it? And copper 2 plus is becoming copper 0. So then definitely it is gaining electron. How many electrons do you think copper 2 plus is gaining to become copper 0? 2. So let me write the 2 reaction halves. Let me write the oxidation half where the zinc solid is becoming the zinc 2 plus aqueous, and the 2 electron that it is losing is over here, 2 electrons that came out. On the other hand, the copper 2 plus must be gaining 2 electrons to become copper solid. Okay? So when you sum this up, you see the 2 electrons cancel, and then it becomes zinc solid plus copper 2 plus aqueous. Now it becomes the same thing that I wrote above, aqueous plus copper solid. So the net total reaction is the sum total of the 2 reaction halves. One is oxidation reaction, we call it oxidation half, okay, and another is a reduction half. And then one of them is losing electron and another of them is gaining electron. So this is we are writing on a piece of paper. Now just think this, if I do these 2 half reaction separately and then we connect them by a conducting wire, like a copper wire, then the electron that is coming from zinc should be moving through that copper wire to the copper side. And if we put a bulb, you will see that the bulb is lighting up. That means electron is flowing, and when electron flows, it is electricity. So let me write the two halves. So oxidation half reaction, which is the zinc is slowly dissolving into the zinc 2 plus, and the 2 electrons are coming, and the reduction half reaction is where the copper 2 plus is picking up those 2 electrons to get the copper metal. So what I'm doing now, I'm really kind of practical way. I have this half shell, okay. There I have zinc metal, like a piece of zinc rod is dipped into a solution like this, and I have some zinc ion in there, Zn2 plus. Now how can I get some zinc ion into solution? You dissolve some zinc salt that dissolves in water, zinc chloride or zinc sulfate, something that dissolves in water. That will give the zinc ion. So that is one half. And then in another one I make another half, like another pot, another beaker, and I have another copper rod in there, and then I make a solution containing the copper ion in here, copper 2 plus. So this is the copper rod, and on the left side I have the zinc rod, and we connect the two, and there is a voltmeter in between to see if there is any current going on. So electron will go, isn't it? Because the zinc will lose the electron, and that electron will move through this wire to come to the copper side, and the copper, that 2 electrons will then be picked up by the copper ion. But you see, the circuit is not closed. I have only one connection. When the electron comes, the zinc will produce a zinc 2 plus ion into the solution, then it is becoming positively charged. That is not possible. So what you do is you put U-tube filled up with potassium nitrate solution, KNO3. Okay? KNO3. Okay? And the two side is plugged with some membrane, so the solution and the ion can pass, but it doesn't fall into the solution. So if that be the case, you see what will happen, the voltmeter is showing that the electric current is passing. Now, how the electron is producing? The zinc metal is dissolving, and it is producing the zinc ion, and the 2 electrons are being produced. That electron will move through this outside copper wire, and then will come over here and go through the copper rod, and then this, the copper rod come over here, and then the copper 2 ion then is going to gain those 2 electrons and become copper metal. So it is going to collect onto this copper rod. Okay, so you'll see this layer of copper metal is getting collected over here. So what happens? Copper 2 plus is getting depleted from this solution, isn't it? But the anion that was with the copper, like the sulfate ion that was there, it needs a counter cation. The copper 2 plus is depositing. So it needs some counter ion for the sulfate to stay in the solution. How that happens is the potassium ion then flows into this side, Ka plus. So now the sulfate anion has the cation to keep the solution neutral. And on the left side, the zinc cation is coming by the dissolution of the zinc solid metal. So it has the positive cation, so it needs equivalent amount of the anion to balance it out. So the anion that comes out is the nitrate ion that comes over here to counterbalance the cation charge that is coming due to the zinc ion being formed. You see that? So that is what is being served by the salt bridge. So this is the salt bridge. Let me write that. Salt bridge. And the side where the zinc metal is getting oxidized to the zinc ion is called the anode half cell. And the side where the copper rod is getting reduced is called the cathode half cell. And the copper rod serves as the cathode. And the zinc rod serves as the anode. And the electron flows from the anode side to the cathode side. So this is the way the electron flows. You just connect those and you see the reaction will continue and continue and continue till all the zinc has dissolved out maybe, or maybe there is no more copper ion in the copper sulfate solution on the right side. But so long all those zinc and the copper metal is there, the reaction will continue. You don't have to do anything at all. Spontaneous reaction. So let me write what really is happening. In this, electron flows from anode half cell to cathode half cell. And when that is happening in the salt bridge, the anion moves the nitrate, isn't it? It moves from the cathode side to the anode side. Moves from cathode to anode side. It is not really moving from the cathode itself, but from the side. And the cation moves from anode side to the cathode side. So this is therefore the galvanic cell.